From ContainerDays Hamburg, this video is proudly presented by ATIX IT.
So today we are talking about how to build operators in Go. That's Michael's part. My part will be an introduction, like we'll talk about the operator pattern and what to do with it, and maybe what you shouldn't, or maybe you should think about doing it before you do it. So let me introduce ourselves. My name is Vincent. I'm DevOps engineer, I guess, meaning I do lots of stuff with Kubernetes, CI/CD pipelines, and the whole ecosystem, which I really enjoy. Prior to that, I was a Golang developer until I think 22. But then I dove really into the infrastructure side of things. And yeah, when I started out with Kubernetes, I also stumbled in the home lab stuff. And yeah, so home automation is kind of a hobby of mine. Talk to me about Home Assistant. Yeah, let me introduce Michael. Michael?
Hi,
sorry.
my name is Michael. Yeah.
Is it?
Is it? As you can read.
Sorry.
Yeah, I'm working at as an IT consultant for the ATIX AG, but you know that could be anything. So mainly I'm working at a full stack developer, mainly for Golang and TypeScript, and yeah, since a few years also in Kubernetes. Yeah, that's from my side.
Thank you very much. Before we go in, just two quick words about our employer. We are a consulting company from Munich. We are about 50 people and we do everything Linux related, and derived from that we started a long time ago with Kubernetes consulting. We also give trainings and stuff, and recently we launched our own yeah, should we call it operator?
Yeah, we can call it
it's an operator. It's called Hunger to deploy Kubernetes clusters in pods. We can talk about that after the talk if you want. So let's get into it. I wanted to be sure, so I looked up the definition in the Kubernetes docs just to be really sure what's the difference between a controller and an operator. And if I get it right, the real difference is an operator is concerned about custom resources, and the controller, like every process in the controller manager, is concerned about the built-in Kubernetes objects like pods, etc. You know about it. So, why do Kubernetes operators really matter? Because even though Kubernetes is in itself a great tool and a great ecosystem for container orchestration, it can be not enough. But it is maybe not the solution to just throw an operator at everything. To deliver my point, let's get into a quick example. Maybe some of you have been there, like a config map has changed, and I just picked a random example from the Kubernetes docs again, and you have an application that has to react in some way to this change. Does it or does it not? So we have this really base example. It doesn't matter if it's a pod or a deployment. This thing just gets the file that is mounted from a config map as a volume, and as you can see, after a few seconds the output changes. So in this tutorial they edited the config map and they showcased, hey, if you use bash in your or shell in your pod and you change the volume, the config map, it gets updated almost immediately, which is nice, right? So no need for any operator there. Problem is, this was just a shell script that echoes a file. If you have an application, it doesn't necessarily react to changes in your config map, right? So maybe the best option, I put best in quotation marks because it's always a bit debatable, If it's your own application, it would be like implement something like Cobra or something that can work really well with environment variables and or files and just watch the file. If it changes, yeah, you reload your config and you are fine. Maybe it is not your application, or it's just some legacy stuff that you can't touch, or you don't know how, or you aren't allowed to, not your responsibility. So bad luck. So let's just build a Kubernetes operator that changes or that restarts our application when the config map changes, right? That's maybe a bit overkill. Just because we are inherently an open source community, let me just give you another way out. You could use maybe this. This is from KiwiGrid. Maybe the one or the other person knows this. It's just a sidecar container, and it's really simple. It just watches labeled. I think this is the labeled one. Somehow, it watches config maps and secrets you want to watch, and if something changes, it notices that, and it can fire some HTTP request, which is nice because HTTP is also the language or the protocol that the API server speaks. So if you would be, or if you wanted to be really quick, you just could tell the sidecar to just delete the pod, because inherently it should be a deployment or controlled by some kind of other resource. Bam, your application is restarted, nice. And this is an application developer concern, right? So you optimize the application to react better, or maybe your deployment configuration to react better to whatever you needed. So problem solved, nice, no operator needed. But maybe a colleague of yours comes around and says, hey, that's really cool, I want that too. So everybody could share this cool project and go around and say, hey, I've got this, just put it in a Helm chart, nice one, job done. Maybe not the best solution, so I found this. Maybe this is a known project, it has a lot more stars, I wasn't aware of this, to be honest. But this is a controller. A custom controller. It's not an operator because it doesn't interact with any custom resources. This boy here is just an operator. Now I got it wrong too. It's just a controller that watches Kubernetes secrets and stuff, and it also works through annotations. So this thing is not an application concern because inherently you are deploying something that changes your platform, right? Because Kubernetes is the platform you host your applications in. So, is it an application developer or someone who is responsible for the application? Is it his concern, or is it maybe the platform or admin or whatever you want to call it team's concern? It's the, let me just say the platform team's concern. So what they could do is they roll this thing out and then they change the platform in a way that the application developer who needs his application restarted or done whatever to react to a config map change or secret change, they are now able to annotate their resources, and then this custom controller reacts to this. So he watches those secrets and he knows that some resources need to be restarted on change. Nice, but a real difference between this one, where you could just throw this thing inside your Helm chart and be done, and no escalation or maybe involvement of another team is necessary, compared to this one, where you change your platform. This one is a platform team's concern, and it's written in Go. I know that this is not the Gopher, the Go logo, but the Gopher is much cuter. So are operators for you? And let me answer that with a really, really decisive, well, it depends. You know what I mean, right? It's always a bit dependent on your use case. You could use an operator pattern to manage your highly complex application, or maybe stateful application that just can't be put down like every other stateless pod in a deployment. Maybe it has to run a backup, maybe it has to do some other stuff, I don't know, something that's not necessarily covered by the primitives of the Kubernetes ecosystem yet. It is a use case, but I really have to say it depends. Because if you do this, then you have to do two things. The first thing is you have to work really close with your platform team, because you shouldn't, or maybe you have, but it's a concern that you are altering the platform, so the platform team has to get involved. But it's doable, especially if you are doing real DevOps, or if that even exists, like just if you talk to each other a lot and maybe the admins or the platform team is really involved in the application, then this is really possible. But what you also do from there on out, you maintain two pieces of software. You maintain the operator itself, and you maintain the piece of software that the operator is then managing. So you should think about that real hard before you really go for it. It can help a lot, and it can leverage your application to another level, especially if you want to maybe ship it somewhere. Then, of course, maybe it's a good idea. If you have this one application that's really complex and that you have to really think hard about how to deploy in Kubernetes, you should think really hard about if this platform is meant to, or if this application is meant to run on Kubernetes. Maybe it's not. If you have to change and alter a platform in so many ways to run this application, maybe the platform wasn't initially the right one in itself. Maybe just the VM is better. I know, unpopular opinion, but it happens. And the real cool use case for operators is the second one. You can use an operator to split the concern between the platform and the application team. And that one is, let me give you an example I wanted to do. If anybody attended the hotel talk, the first one of this conference, he did mention something like that too, but I couldn't talk to him anymore, so I fall back to my usual example. Everybody knows the Kubernetes stack, right? And Kubernetes, or Prometheus, so to say, is monitoring. And monitoring is a concern of the platform team. Like, you shouldn't give your developer or the one responsible for the application the power to bring down your monitoring, right? Not a good idea. But still they want to partake in this. So what they did on the Prometheus side is they give you the operator that it does a lot of other things, but the thing I want to point out is they give you this custom resource called Service Monitor, for anyone not aware, and this Service Monitor can be deployed or even integrated in application Helm charts to make this application scrapable or a target for Prometheus. So you have on the one side the platform team that is inherently worried about stability and resources and their observability. So they manage the observability without the application developer being able to put it down. And still the application developer can use it and enhance the monitoring. So that's a real nice use case. What's the next slide? Okay. So before Michael will show you Kubebuilder, let me just, I basically said everything there is, but one thing, operators are idempotent, so like Ansible, they should always reach the same result, etc. They are meant for automation. Like what I didn't mention is that you can use operators to transfer operational knowledge or to automate operational knowledge, right? Everybody knows it. You have a CR, you have the specs that you can fill out, and the rest is managed by the operator. Simple, much simpler than a Helm chart or manifests or whatever. But it comes with a price. You have to know both ends. You have to have a good knowledge about Kubernetes and how it works and how the reconciliation loop, etc. works. And also you need a big knowledge about the application you want to manage. And there it comes again, it's an involvement of the platform team required, because you will alter the platform, and the platform is the concern of the platform team. So if you don't have this cool setup where you own the whole cluster or where you are really good friends in a DevOps way with your platform team, then it's a totally different thing, and it's always kind of doable and something to think about. But that's what I want to give you to think about. Of course, you have security concerns because you're introducing new RBugs into your cluster, etc. But then again, like I mentioned already, you use the standardized and approach that's meant by Kubernetes, because Kubernetes is, of course, meant to be extended to fit your needs. So just to give you the last example, if you are a platform team and you want to give out for maybe development purposes a keycloak, then of course you should, or maybe you could deploy the keycloak operator and give the ones that should use it the RBUG permissions to deploy those custom resource and yeah, for whatever development and whatnot, deploy their own keycloak. And then again, if you are the admin team and you have a really big keycloak for your IAM and stuff, then maybe it's even good for you to have the operator manage your whole big one keycloak instance, even though it's just one. So you can use it to ship many instances and rely on their consistency, but you can also, of course, manage the lifecycle of your complex or more complex or stateful applications more easily. So, yeah. Are operators for you? I don't know. So before we dive in Kubebuilder, let me just get it straight so we are on the same page. The CRD is the definition that you apply to the of course to the API server, but the API server gets extended, and the custom resource is the instance that then the API server knows about what to do with, because it got a new API path, and yeah, the operator is the one who is inherently then watching this custom resource. So here you can see, I guess it's a non-exhaustive list, but this is straight from the docs. So you see there are a lot of different options when you're building operators. So it's not necessarily needed that you write a whole lot of YAML CRD schemas and create the boilerplate, because there is some boilerplate involved in this operator pattern. But as you can see, there are many different tools to fit, hopefully also your needs. We are sticking with Kubebuilder because Kubebuilder is the one dedicated in Go. And just to mention it, Kubebuilder is also available as a library in the operator framework itself, that you can see the second from the bottom. Just a mention. So.
Okay, then I will continue and want to show you how to create an easy operator. First of all, what is the problem in building an operator? In the operator pattern, it's all about reconciliation. Like Vincent already said, you have to build it idempotent. It means that the state your resource had doesn't matter which against the outcome from your operator. As you can see, that's loop. There are 4 phases: observe, compare, act, and update. This means that you check your state, which is on the cluster, compare it with the desired state, maybe act to get the desired state, and at the end update the status or something like that. And then the reconciliation loop gets called again and again and again. Every time maybe the spec has changed or the status has changed or only a field is changed of your resource. That's the main thing about it. I want to show you how to easily create an operator with Kubebuilder, because Kubebuilder is a real powerful tool. You don't need to do that much to create an operator which you can deploy to your cluster. Mainly you have to use 2 commands. First of all, you have to init the project, give them your domain and your repository. And the second step is to create a resource or create an API, it's called here, that mainly creates a resource and a controller which is related to that resource. After that, you only have to define your CRD, the fields you want, the spec you want, and the only thing you have to do is implement the controller. So that sounds easy. You only have to implement one method. That's the good thing about it. The bad thing about it is this method has to handle everything. Yeah, and if you're finished with that, you can let Kubebuilder generate your manifests, for example, which are necessary to run your operator in a cluster. For example, some cluster roles for leader election or something like that. But this is all generated by Kubebuilder, so you don't need to do anything for that. And now let's check it out. Can you read it? Probably not. Get a little bit upper. So first of all, we create some tests here. And then I will init a Kubebuilder project. Okay, the project is already existing. I'm in the wrong directory. Just a moment.
We've all been there.
So now Kubebuilder has initialized our project, and now we want to create some resource and related controller to it. That we do also with Kubebuilder. We create an API in the group apps. It's the version v1 alpha 1, and kind is my resource. That's how I called it. And if I do that, Kubebuilder will ask me if he should create a resource, and we will answer this with yes. And also, we are asked for creating a controller. We also will answer this with yes. After that, our project is set up, and we can use it, I think. Sorry for that.
Thanks.
So let's have a look what Kubebuilder have created for that. I don't want to go to every folder because I only picked the relevant for us. The most relevant part is the API part. There you can see, or there you can write your custom resource definition. You can see Kubebuilder generates a lot of code. Let's set some boilerplates so, which you can use. It's super easy. You have here the definition of the spec of your resource. Here also is an example how to adding properties to that. You had a status, it's fully empty. You got your resource itself, and you got some list for fetching it from kubectl or something like that. That mainly working, it does nothing, but you can deploy it for example. The second thing is the internal folder. In the internal folder, there's your controller, and also a boilerplate for tests is generated, so you can do your tests also there. And you will see there's only one method, the reconciliation or the reconcile method. Okay, there's another method, but yeah, that's for creating a client. And the only thing you have to do is to implement this method. Yeah. After you are finished, you can you got this config folder here. There's a lot of stuff in it, but not now. It's coming when you create the make files for generating the manifests which our controller needs. But I will show you this on another project which I already prepared. You even get a Docker file to build your controller. So you're fully ready to start if you create a project with Kubebuilder.
Yeah. So while he he changes the project, so you also have your Docker files there, but also testing and yeah, the real boilerplate you need to start out your operator with the business logic, which is kind of nice. And you can use the make file, which is also added to like generate your CRDs and whatnot. I think you will show this now. Oh no, sorry, you don't.
No, I added some informations to our struct, for example. I created some phases. You can define what you want. Yeah, it's you can define your conditions, your own conditions, which suits to the project you are developing. So feel free to try out. Like you see, we had two fields, name and replicas. And we got a status which contains a phase at which our resource is right now. We got an array of conditions, and we got some helper fields. Observed generation is used to determine if spec has changed, but status not. So this would be the case if I want to update something, or for example. And unavailable since is yeah, it's a time span. It's used to determine when a resource is running, for example, at which point we mark it as degraded and try to regenerate it. You can see Kubebuilder has generated here a lot of annotations. For example, this printer column output, that's when you fetching our resource from a cluster, and you can define your own fields which should print it out. So that's a cool thing. Yeah, that's the only thing I changed here in this file. And the next step we need to do is to generate our controller, or to implement our controller. And as you will see, this method is a little bit long, because yeah, it has to handle the full life cycle of our resource. So maybe we step through it. First of all, you need to get your resource from the cluster. It could be that the resource is already deployed, for example. That's what we showed with the reconciliation loop graphic. It shouldn't depend at which state your resource is when this reconciliation method is called. It should kind of handle it. First of all, we check if it's marked for deletion. If it's marked for deletion, you can see I set the phase to terminating, and I set some conditions. And that's mainly the important thing of writing the reconciliation loop, because it's all about state handling and set conditions. Because after this, nothing more is executed. We will step over all this and update our status here at the end. And then the method is triggered again, because our status, because our phase has changed from nothing, which is the state if you deploy a new resource, to pending, because or to terminating in this case. So that means in the next run, the loop will step in at the deletion part here in terminating, and there we just drop our resource, and then it's finished and everybody's happy. So you can add there some finalizers or stuff like that if you have multiple resources which you are deploying and want to make sure that everything is deleted in the correct direction or something like that, or in the correct order. Yeah, that's the main thing. And yeah, that's the way how the operator is working. So you reach it, then you check some values, you have to change your phase, and then it's run again and hits the case block in another phase. So for example, this point was this is the case if you deploy a newly resource, it won't have a status. We check that, we see, okay, we set the status to pending, and then we quit, and in the next rotation, we won't join the pending phase. And here, we just creating our deployment. So in my operator only creates a deployment which is creating an Nginx or something like that. It's really easy, and that's all about, yeah. So then after you deployed your resources, you switch to running phase, do some health checks or something like that to determine if it's ready, or probably it's degraded, so we need to handle something. And in our degraded phase, I only redeployed the resources, I think. That's the easiest way. You can do there probably something, some stuff like routing updates or so. But we're out of time, so let me quickly show what we have done. I will open here K9S. And so I've created a test file. Let me quickly show you. It's only a YAML manifest for our resource. There you got your API version or the group, and you got some metadata and some spec. It's super easy or super small. Let's deploy that. You can see our resource is created, and now I can filter for my resource. And you can see there is my resource, and there's no phase, and it's not ready. Because, but why is it so? Because I don't started the operator. Oh, schlecht. Just a moment.
So what you will see in just a second is the custom resource will deploy, the control will deploy the deployment. It will create the deployment. Ah, nice, it's already there.
So now let's try again. Now you see it, we got a phase running and the state is ready. Yeah, that's because it started so fast that we skipped the pending phase, or the pending phase was so short that you won't see it. But you can see, you can open your CRD, CR and can check your state, for example. We got here observed generation, that value I set when first time the state is switching, the phase is switching to running. Yeah. So you can see there's the fields we have configured. You got some conditions, for example, it's ready, it's true. And you can see in the namespace demo, there should be a deployment, and this deployment should have a pod, and everything is fine. And if I delete now this deployment, oops. Our operator should, at least in probably 10 seconds, recreate it. At least I hope that.
Rural.
Yeah, looks like
I think your operator died again.
Yeah,
just
crazy.
imagine that they deploy. No, you know, it's a really simple example that we set up for this talk. So yeah, usually what would happen is that the operator notices through his reconciliation loop that the CR, that the resources under the CR are gone, and he just, like he said, in the degraded state, he just recreates the deployment. And
yeah, it looks like the degraded state is broken.
I think it's fine. Thank you very much. We have 1 minute for your questions. Sorry about that.
Sorry about the demo.
Should I still bother with building my own CRD controller when Crow is around the corner? So what use cases would still justify the effort, and where to draw the line? It's the very first one.
To be honest, that's the part I missed. My colleague Pascal told me about this talk. I still have to look into it, so I can't really compare. Maybe we can talk tomorrow about this. I'm sorry.
That was a fast answer, so maybe a fast second question. Does Kubebuilder generates a ready-to-use Helm chart for the operator, yes or no?
Yeah, not really. You can use customize, for example, but I can share my screen again. Kubebuilder will create the manifest files which you can use to add to your Helm chart, for example. So you can build your own Helm chart, which also deploys the CRD. I think Helm, since version 3, supports the CRD folder, and whatever for CRDs you put in there, it's deployed to the cluster. So it's no problem to build your own Helm chart from that. So you got mainly all resources which you are needed for that is created from Kubebuilder. I think the only thing is missing is the deployment for your operator itself. Yeah, but that shouldn't be the problem.
Good. So time is unfortunately up, and given evening event is awaiting, and I think all of you are looking forward to it. There's two things. One question, like, which operators did you work on for your home lab? None. Okay, that was also a fast one, because I thought it's perfect question for a beer. But maybe the others are too. And I will definitely also make a screenshot for you so that you can still have the chance to think about it, answer about it. You're still around also tomorrow, right?
Yes, he will.
Yeah, I am still
I'm
here
leaving today,
tomorrow.
but, yeah.
You can always chase me around the booth at a venue and ask me all kinds of weird questions. That's what I'm here for. I will ask back.
Awesome. Then, thank you both so much for your great talk and the demonstration.
Thank you very much. Thank you for the moderation. And thank you all for attending.
From ContainerDays Hamburg, this video is proudly presented by ATIX IT.